It's May 22, 1520. We're working here, Eric Wingate and Randall Von Wedel with Christine Thibodeau. We're just about to demonstrate what might happen as this degraded oil slick approached a sandy beach within a marsh. This is reference sand, and this is actually coffee ground material and detritus that we collected from a marsh near North Bay on May 19 to the east and north of the opening of the Mississippi River. This is the actual oil that we carefully collected and kept cool until today to do this experiment. The oil is quite warm. I can feel the heat coming off of it. It's probably 90 plus degrees here in the ambient temperature, and we're about to create, for lack of another term, a slow-moving oil tsunami. You see that the oil has a tendency to remain coagulated. It's not tending to streak. Now it's reached up to the high tide mark into the detritus, which is very absorbent and very biologically active. Being observed by helicopters, we were on the 19th. So this would simulate the late afternoon, hot sun, no wind, high tide mark, where the oil's reached all the way above the sand and into the detritus. And now we're going to gradually lower our pool down to simulate a rapidly moving, receding tide. As we've observed earlier today, the oil tends to be rather coagulated. It streaks. There are little patches of it that remain, but it's surprising how little tackiness and how it's really not that adhesive. It does collect on the sand. It's clearly going to collect on the woody stems and shafts of the plants along the marsh. We don't know yet what impact the oiling of the plant will have, but it was clear when we were there on the 19th that the oiled marsh plants had their greenery and photosynthetic leaves were way above the oil level. So this soupy mess has the consistency of warm Hershey's chocolate, and surprisingly even has the same color. But we've established that it's only about 15% liquid petroleum oil in this state. It's just deceiving to see it. It looks like oil, but it's really an emulsion or a mousse with low levels, proportionally low levels of oil. It's over 50% water, and of course it's an emulsion with air. We showed that with our cytosol product that we can cut this oil, this emulsion, and quickly separate out the oil from the mousse and achieve a quick break of the emulsion to free the water, so that when this is collected inside of a barge container, it can be treated and separated. The water discharge is clean water, and then that area, the water itself, the equipment, and the surrounding residual hydrocarbons in the marsh would be treated with a product called Proteus 168. The 168 is a mixture of a mild surfactant. It's very quickly degraded, but it will have the effect to speed up the biodegradation of the residual hydrocarbons. The product includes nutrient, so the nutrient and the surfactant would help to break up these residual areas of hydrocarbon that would remain in the sand. In our next phase, Eric Wingate from Proteus is going to demonstrate spraying this particular beach with his product.